Good to have you here. This is Unintended Consequences, episodes Eventeen for May 28th, 2026. This is a show about what happens when smart, well meaning people try to fix something and the world fixes back. Engineers built smartphones to put the world's knowledge in every pocket and created 50 million tons of e waste a year instead. In the yards of Agbogbloshie, Ghana, teenagers pry open smartphone casings with screwdrivers and set the plastic on fire to free the copper wiring inside. The same devices that once fit in a shirt pocket and connected users to maps, banking, and distant relatives now release thick smoke that carries lead and brominated flame retardants into the air. This outcome was never the plan when engineers set out to shrink a computer into something anyone could carry. In the late 1990s and early 2000s, teams at companies such as Nokia, Motorola, and later Apple and Google saw mobile phones evolving from voice-only tools into pocket-sized computers. Their explicit goal was to give ordinary people instant access to information, navigation, photography, and communication without needing a desktop machine or a landline. The historical context was the rapid spread of the internet and the recognition that most of the world would never own a personal computer. Designers therefore treated miniaturization, constant connectivity, and frequent software updates as unqualified goods that would close the digital divide. They worked with the data then available. Component costs were falling. Wireless networks were expanding. User demand for new features appeared insatiable. The assumption was that newer, faster phones would simply replace older ones the way color televisions had replaced black and white sets, with disposal handled by existing municipal systems. Between 2007 and 2015, the industry scaled dramatically. Apple's first iPhone shipped in 2007. By 2015, global smartphone shipments exceeded 1.4 billion units annually. Carriers subsidized handsets on 2-year contracts, and marketing emphasized annual model refreshes. Early indicators of success were clear. Mobile internet traffic surpassed desktop traffic in 2016. Smartphone penetration in low-income countries rose from under 10% in 2008 to more than 50% by 2020 in many regions. Proponents pointed to measurable gains in agricultural market information and financial inclusion. Few formal warnings about end-of-life volume appeared in product announcements. The dominant engineering focus remained on thinner casings, higher screen resolution, and sealed batteries that improved water resistance and user experience. The same design choices that drove rapid adoption also shortened usable life. Soldered memory, proprietary fasteners, and software that ceased supporting older chipsets made repairs uneconomical for most users. Average replacement cycles settled between 18 and 36 months. Because collection programs captured only a small fraction of retired devices, the remainder entered informal export streams. By the mid-2000s, an estimated 50 million tons of electronic waste were generated worldwide each year. A substantial share of smartphones and feature phones reached sites such as Agbogbloshie in Ghana and various yards in Pakistan and India. Workers, frequently including children, burned insulation to recover copper and gold, releasing dioxins and heavy metals into soil and groundwater. The causal chain ran through economics. The marginal cost of producing a new phone fell faster than the cost of safely recycling an old one. Export rules under the Basel Convention proved difficult to enforce for small, high-value items. Second-order effects included depressed local repair economies and health burdens on communities that had never been intended as disposal sites. Third-order effects appeared in global supply chains, where the constant demand for rare earths and cobalt encouraged new mining even as usable metals sat unrecovered in discarded handsets. Once the scale became visible, governments and manufacturers responded with take-back mandates and voluntary recycling targets. The European Union's WEEE directive and later right to repair proposals required greater parts availability and easier battery removal. Some companies introduced trade-in programs and modular prototypes. These measures have increased formal recycling rates in wealthy markets, yet the global flow of used devices to informal sites has not stopped. enforcement gaps, and the sheer volume of retired units continue to outpace regulated channels. A secondary consequence has been the growth of a gray market in refurbished phones that extends device life but still leaves the hardest to process components for informal handlers. Design decisions made early in a product's life determine its end of life cost more than any later recycling program can offset. When performance incentives reward only the moment of sale and not the full material loop, volume grows faster than recovery infrastructure. Systems that treat disposal as someone else's problem reliably shift that problem to places with the least capacity to absorb it. The open question today is whether the same engineering talent that once concentrated on thinner phones can be redirected at comparable speed toward devices whose materials remain recoverable at the end of a deliberately longer service life. That wraps today's case. The lessons travel further when you share them. Send this episode to someone who'd find it useful. We'll see you tomorrow. This episode used AI voices synthesis of my voice. Editorial selection and analysis are my own.